The supply of food can feed 12 persons in 50 days. How many days will the supply last for 15 persons? For this problem, there's no indication as to whether this is under direct or inverse or other types of variation problems. But when you look closely at the situation, you could see that the supply of food can feed 12 persons in 50 days. We have two variables here, the number of days for the supply to last and the number of persons who will be feeding from that said supply. When you look closely at the supply and number of persons who will be feeding from that said supply, the more number of persons who will be feeding, it would actually take the supply a shorter amount of time. And if we're going to have the lesser the number of persons, it would take the supply a longer amount of time. So this is actually an example of a variation that involves when one goes up, the other one goes down, and that's actually an inverse variation. And we can see that from the said situation, it's the number of days for the supply to last that is actually dependent on the number of persons. So again, it would be y, our dependent variable for a number of days for the supply to last, and your independent variable is actually represented as x for the number of persons who will be feeding from that said supply. Even if there's no statement that will give us varies inversely or something like that, we are now sure it to be inverse variation. The general mathematical equation for inverse variation follow this formula. Y is equal to k over x, where k is the constant of variation or the constant of proportionality. We will be solving for the value of k first, depending on the available data, and we'll be using that value to solve for the unknown. Take note that it's in the form of a fraction or a rational expression, as different to the direct variation, because this follows the concept that when your independent variable will get large, your dependent variable will get smaller, or vice versa. Now, before we could use that, let us of course again declare here the variable given. We know that y stands for the days for supply to last, and x will be the number of persons. In the first part of our problem, we know that the supply of food can feed 12 persons in 50 days. The number of days is your 50, and the number of persons, x, will have 12. So this is your first pair to be used in solving for the value of k. And we'll be using the second pair, which is here, how many days we're looking for, a number of days. That's your dependent variable. Now the number of persons increased to 15. So let's start with this pair. In substituting here, we know that for 50 days, we'll have k over 12 persons. So we'll be solving for this k here using the multiplication property of equality by multiplying 12 both sides of the equation. By multiplying 12, we could cancel this out, and we will have k, which is equal to 12 times 50, which is equal to 600. This is our k. And then we will be using that here on the same equation, y is equal to k over x. And we'll be solving the number of days for 15 persons, the same amount of supply. So we'll have y is equal to k, which is 600, over x, which is 15. So simply divide that and you will get a result of 40. This means that the supply will last for 40 days for 15 persons. This is in relation to the problem given. Before we end, notice what happens here. As the value of the independent variable increased from 12 to 15, you would see that the value of y, which is the number of days for supply to last, decreases because there is an extra, or there are extra persons to be fed using the same amount of supply. This is how we solve a problem like this for inverse variation. The more you practice, the better the chance to understand math. This is a direct variation statement for math success. Let this k, the constant of variation, be this channel. In other words, the more you practice with your subscription, the better the chance to understand math. Subscribe now.